This video tutorial explains how to calculate the Simpson Index in our biodiversity lab. As explained in the lab, the Simpson Index is used to compare both species evenness and species richness. The higher the Simpson Index value, the greater the biodiversity. The lower the Simpson Index value, the lower the biodiversity. Now this video only concerns the Simpson Index calculation and no other parts of the lab. If there is a muddiest point for students calculating the Simpson Index, then it probably involves finding the proportional abundance. The proportional abundance is used in the Simpson Index formula to derive community diversity. While the steps to find proportional abundance are described here clearly and explicitly, students sometimes either get tripped up or they just give up. But the math is really quite simple, and your calculator does all the work for you. So let's begin by simply reading the instructions here. To find proportional abundance, divide the number of individuals of that species by the total number of individuals of all species in the community. So if we scroll down here to community 1, we begin by looking at our first species and count the number of individuals of that species. And we see 1, here's another one, 2, and a third one, 3. And then compare that, we want to divide that actually by all the individuals of all species in the community. So we count the number of columns, 1, 2, 3, 4, 5, and the number of rows, 1, 2, 3, 4, 5, 6, and 5 times 6 equals 30. So we've got 3 individuals of species 1 that we divide by all the individuals in the community, 30. And when we plug that into our formula for proportional abundance, then the proportional abundance is 3 divided by 30, which is 0.1. And then notice that we square that value, which gives us 0.01. Okay, so we've got the proportional abundance now of species 1. But we need to go on and do that for every single species in the community. So we move on in community 1 to the second species. Here's the second species. And we count 1, 2, 3 individuals of species number 2. And again, divided by 30 gives us a value of 0.1 for the proportional abundance, and we square that value, which gives us 0.01. So we go on and do that for each species in the community, and that gives us our denominator value. We add all these proportional abundances together. That gives us our denominator, and then we take the denominator and divide that into 1. So you can see that the calculations are really pretty simple, and your calculator does all the work for you. Then we go on and do the very same thing to community 2. Scrolling down here, we see here's species 1, and in community 2, I only see 1 individual of this very species. Okay, so we divide that by 30, and that gives us our proportional abundance, which we plug into the calculation, into the formula. Move on to species number 2, and I only see 1 of that species, and so on and so forth. Once we plug all those proportional abundances into our Simpson Index for community 2, then we compare the 2 community diversity values, and the community with the greatest number, with the highest value, is the one with the greatest biodiversity.